All right, so we're back with Carrie's group here in Arizona. Again, a big hand to Carrie for hosting this event. Hopefully, it's been really exciting. I think we've all learned a lot so far. So the next big question is always, okay, what 3D printer do I use? So how do we ever answer that question with the knowledge that we currently have? Right now, a couple that we're using, that I know the club is using, is the FT5. We're also using the CR10. And what are some of the others that are currently being used?
Tivo Tornado,
of course, the Raise 3D, which is what I have, and Carrie has a couple of those. We can speak very highly of those, but again, that's probably one of the higher end printers that you're going to use. The CR10, I think, and the FT5 can be budgeted around $500 to $600. Is that about right? They're both really good printers. CR10 is probably a little bit easier to put together over the FT5, but if you're brand new to 3D printing, the FT5 is a good way to go because you get to fully assemble it, you get to understand how a 3D printer works, how to change the stepper motors, and all the things that are there. But again, it has its faults on some of the materials that you can use, but also is a good affordable starter printer. So up here, so the next thing, what material do we use? So currently, a lot of the club members are using PLA. It's a good material. It's an excellent material to start out printing with. It sands pretty well. It holds paint excellently. It's impact resistant. The only downfall that I know of on PLA is that it's heat sensitive. And the temperature is 100 to 120 degrees. Inside of a car, big no-no. Do not ever leave your joy inside the car, even if it's printed in ABS. It's just, especially if you've got hot glue or anything else involved with it, you're going to create a problem. So you've got PLA, we've also got PETG that the club has started using. A lot of things that I've tested, I've been through InGen, several of the other color fab things on trying to come up with something that we can print the domes with. Because we want them to be super impact resistant and we're trying to get them as light as possible. Through all that testing, which I didn't post a lot of that online, ABS has turned out to be probably one of the better materials. The problem with ABS is that not all printers can print ABS. The only one that I've successfully printed on has been the Raise. And that took several weeks of dialing it in and trying to figure out what the settings were to be able to get optimal printing results out of it. And what that can involve is that temperature has a really big effect on all the different chemistries and how they interlace once they lay on top of each other. And when they cool down quickly or they cool down slower, you'll start getting problems with layer adhesion. And then when you get the layer adhesion, you start getting the cracks in those particular zones. When you get it too hot, you start actually burning the materials when you're putting them down. It's basically a way to put that. So they get fragile, or that's where you can actually start getting the vertical cracks instead of getting the horizontal layer cracks. So it's a very fine line on finding out what your printer will do. And you can always ask someone, well, what printer settings are you using? It doesn't always work. Every printer is a little bit different, and your zones are different, your climates are different. Humidity in the air is different. So that's where I know one of the questions was, what about enclosures? There's a lot of things. You can see the Raise, that it's a fully enclosed 3D printer. But some of the materials that we use do not need to be fully enclosed. PLA is one of those. So once you fully enclose PLA, you start heating that whole chamber up, and now your part is too hot. So now instead of it curing fast enough, it's actually staying wet. So when the head comes back around, it'll actually start bowing it up, and then you have a failed print. So again, there's a fine line of temperature control inside a controlled chamber. They do help. I think there was another question on dust control, some things like that. On the FT5, I've never had any problems with any of that. I guess that goes into maintenance on your printer. So it's once you start seeing something always say, every time I start a new print, I'll run the head across and run the head X and Y. And you see if you've got any resistance on it. And you'll get to where you can feel it. You'll notice if something starts building up really bad, wipe those rails off and re-lube them. And you could always talk with the guys that have done it for the particular printers to see if what they're using, because each printer uses something different to lube the rails. You can use graphite on some of the things, and then you can use a lot of the lithium greases on some, and then there's some other things. There's one called Super Lube that's a really good lubrication for the printers. Is 3D printing good for everything? It has its purposes and its points. I think a lot of the structures and stuff that we've built for the outside, they're very good for. One of the questions we always get is, you know, what is your droid made of? And we say 3D printing, and we say, well, how is that possible? It's so smooth. So 3D printing is not a smooth process yet. You can get really good layers on there, get them down to really fine lines, but then you get slower on what you're wanting to do. So a lot of us want to print them faster. We're always in a hurry on trying to get something done. But this is one, so you can see the lines and stuff in this one. And we've already started prepping this to get it down to be able to get it ready for paint. So that's another class we'll go through a little bit later, is about prepping them. And then you can see a little bit on this one, you can see that the lines are a little bit tighter on what this one is. So again, that goes into prepping, and that goes into, we'll go into that a little bit later on. So what are some of the other questions you guys have, or some of the guys online that may have?
I'll just chime in with a comment really quick, because I've printed God knows how much more than I ever should have. One of the things I learned is when I did my first BB-8, I probably spent, weeks and weeks and weeks and weeks and weeks doing panels after they're printed, just sanding and filling and prepping and painting, and then after that, when I did my second BB-8, I probably cut that time down to a third of that. And by the time I got to doing BB-9E, which is the hardest finish because it's gloss black, those panels I had probably, after printing, I want to say a couple hours a panel. You know, and what I found over time is let the printer do the work. Unless you have to have your BB-8 done for a show this weekend, if you've got months, set the printing speed slow, set the printing height as small as you possibly can, let the thing run for 3 days and pull a good print off. It's going to be substantially faster than printing quick with a high layer height that looks like crud, with layers that have shifted that now you have to go back and bondo and sand and fill, and let the printer do the work. If you have the time, take your time on this. It's not a rush to the finish line.
I got one question. It says, I'm completely brand new to 3D printing as I never printed. What would be the most common mistake to make?
Not calibrating your printer.
Yes.
That's probably the biggest thing that you need to do. Every printer is going to be different when it comes to that. You can try to get it as close as you can. You know, if you're printing a 20 by 20 block, and you get 19.97, that's really good. And you're going to end up with some good parts that way. But it's calibrating it in X, Y, Z, and then also calibrating your extruder. Because the extrusion rate is another variable that will give you a lot of problems. And once you print a 20 by 20, you want to go up to a 30 by 30 and kind of see where you're at. Go up to a 50 by 50 millimeters and see what your variances are in those directions. Find a happy medium on that, and that'll be your calibrated settings.
What about adhesion to the bed? Usually like getting that first layer down.
Adhesion to the bed. So it's a sticky subject. So a lot of people, you buy the printers, they want to sell you something else. So they want to sell you like Build Tack, or they want to sell you, what are some of the others? I know Build Tack is one.
Pre-cut.
Really expensive
all
blue
the
tape.
expensive blue tape. So the one thing I've found, and I think Carrie's using it, I think a lot of people are using it, is we have a piece of glass. We use either Aquanet hairspray, just a cheap not the squirt bottle, but the spray kind.
But that would be for ABS, right?
No,
Because
for
like
anything.
That
for
works
everything?
for anything, really. And then the purple glue stick. Go when it's back to school time. Buy as many as they have. Buy them out.
Yeah.
Goes real
Because
quick.
that has been the best adhesion of anything. So it works for ABS, PLA, PETG, all of those. But the big thing again there is experimenting with what your printer can do. You need a heated bed for almost all of those materials. It can be 30 or 40 to 50 degrees for PLA. It can be all the way up to 110 for ABS is what I'm using on the ratings. So it's extremely hot temperature for that. But you get that adhesion and you stop your failed prints. It may take you longer to warm your printer up, but that's way better than spending 20 hours and your print failing and falling off the bed. So again, like Carrie said, take your time. Find what works for your printer. Find the starting point. And once you have that starting point from a friend or from any of us, just ask us if we have a particular printer that you're thinking about buying, ask the people that are using those printers, hey, what are you using to print PLA with? Okay, let's start with that. And then make one change at a time. Say look at it, if you don't think it's adhering good enough, change your temperature 5 degrees. See what that result is. If you didn't get the result you wanted, go up 10 degrees. There's these things called temperature towers that you can print. That you can go through 10 different temperatures in one print, and that gives you a point there. So after you get what looks good on that, take that and then change your speed a little bit on there. Change your speed by 100 millimeters a second or something, and see what that does. So then you'll start understanding what 3D printing is doing. So there's 4 or 5 variables that you can change on that, and each one of those will have a different effect on what your end print looks like. For ABS, to get this dome where I've had it, I cut a section out, and what I did is printed about 60 of those through different materials. I would try different ones, say 10 per material, and see what they would do. And I would try to bend them, break them, see where they were breaking at, what were their failure points, what were their failure modes. Do they just bend over? Do they crack? Do they fracture? So all of those things you'll start learning. If it's fracturing, you're probably too hot. Some of the materials are just not meant to be fracture resistant. They're meant to be really stiff parts for printing something really thick. But then when you get thin, you start getting fragile, and you'll start snapping parts. So a lot of that's also knowing your materials. There's a lot of good data in the club on what people are using, but not a lot of, and I'm one of the ones that failed to do that on posting my failures. So that's one thing we need to get better at as a club, is letting you guys know what we're testing, what we've been through. Like, most people don't know that I went through, 10, 15 different materials to test, to find out what's the best that we can get, the best, strongest dome to get it as light as possible. One thing ABS has is it has a thinner cell structure. So you end up the same dome printed with the same settings on PLA or PETG. This dome is about a third lighter than some of those other materials with the same thickness, same infill, same everything. It just has a different cell structure, which makes it a little bit lighter.
I got a quick question for you.
Okay.
Have you noticed through manufacturer, color, and like where you get a supply of difference in materials too?
You're talking about like the
filament?
material quality?
Yeah, quality, fillers, how they print. Because I've noticed like
Yes.
black colors print in lower.
Colors,
or
all
higher
colors print differently, so that's something else. Every roll, if you get this ABS in white, you get the same company, same size material, but in black, it's going to print totally different. So you'll have to go back through, you'll recalibrate for that color. They're not big differences. They can be subtle to 5 to 10 degrees on your print head temperature, your time, your extrusion rates. I mean, you can have a lot of different materials string differently, so you'll have to set your retraction a little bit different. So just pay attention to those. When you get one, you say, well, this material sucks. It doesn't print as good as what the other one did. Well, it could be just that the color is different. Another thing you've got to watch out for is you can get a lot of cheap filaments out there now. Cheap doesn't always mean it's gonna go well. So you've got to watch, and one thing that I'll do when I get a new roll is I'll pull it out, I'll take and measure the size of, 30 feet of that roll. Roll it out and see what your filament diameter is. And that, for one, lets you know, I mean, if there's a big glob, 10 feet in, you want to check it, take that out. If there's one 10 feet in, you probably got a bad roll of material. Send that back to the vendor and have them replace that roll of filament instead of trying to fight it, because it'll be an endless battle if they've done it, in 20 or 30 feet. The whole roll is probably not good. So, just another word of advice there. So,
Got one question
Okay.
from Lee Thompson. What glue do you recommend for PLA? Would friction welding be better, as PLA doesn't really glue well?
the one that I use for PLA is Weld On 4 or 3. It's a very viscous, I mean, it's just almost just like water on putting it on. It's pretty toxic stuff, so make sure that you wear gloves using it. I mean, it's not going to kill you or anything, but just so if you don't, I mean, because if you do use it and you put it on the dome, it actually, the PLA will stick to your finger just like glue. It's like super glue basically when you do that. But what that does, what Weld On 4 does, is it actually melts the material, so it's a soluble. One thing that I'd like to do, and I worked in the sign industry for a long time, was trying to figure out what we could do to put substrates together. Just like friction welding, I mean, you're basically melting those two materials and adhering them together. So you can take print you a piece of the material, put the material on there, and see if it gets gooey when you put the glue on there. Unless you're using like CA glue or something like that, it glues everything together. But CA glue has its fracture points too, or failure points, is that it's not impact resistant. When you put like a three-piece dome together and you drop it, you'll end up cracking that seam. The Weld On 4 gets by that because it actually welds the two, or melts the two together.
Got one more question. Is there a method for printing the round objects like the frame triangles, like in what orientation?
Orientation, that's good. Okay, so almost all of us in the club, or somebody in the club, has tried to come up with a way to print any of the pieces of BB-8. We all have come up with different methods on doing it. My method, I think, that I've liked a lot, and Terry's using, I think Bobby, I think a lot of Stefan's using it, is that for the one-piece triangles, we print them on a tilt. And you're trying to get all of this surface on the bed. One thing we need to do as a club is we need to send that file set like that, I think, because they're coming in one way or another. You can't tell it to choose a flat zone here and tell it to go flat to the bed, because it'll never do it. So on the ones from the club, I just take and I mess with it in the printer until I get it exactly where I actually drop this below the bed height just a little bit, and then I can look underneath. If you're using S3D, you can roll around and look underneath and see if you get just a very fine line, so you'll know you have it exactly oriented where that's at. And what we found is that you don't need supports when you do that. Now you can print this. A really good calibrated printer will print this and not need any support structures here. We do have some that will put us, 3 or 4 support structures in those zones. And I think Bobby White has come up with a way of using helper discs turned sideways. One problem that we've saw, and especially I've tried to do a lot with ABS on this, is that during the first probably half inch of this print, they'll actually lean over. And then you end up with a warped edge here, and you can't ever really recover from it. So what Bobby has done is come up with a way of putting helper discs sideways, turning them up on their side, and putting 8 or 10 of them along that zone, and that has really helped to straighten that curve out on that zone there. Same thing with the 3-piece parts. Which way do you guys print these?
Sideways, yeah, like that.
So you'll again twist this one sideways and you'll print it on its edge. This is for the smaller printers. So just so you know, I mean, you don't have to go out and buy a 12 by 12 by 12 printer. You can have the 6 by 6 or the 8 by 8 printers, and you can get away with doing the smaller 3-piece. The only thing I see about that is just like Carrie was saying earlier, now you've created a lot of work for yourself on having to go back and finish. All of those parts, if you're as picky as I am, you'll never get them as smooth as what I would want them to be. So that's why I went with the 12 by 12 initially on the FT5, was to get the one piece. Circular panels, we've gotten to where we print those laying flat on the bed. You do need to use supports. Do you use supports on your
I
skin?
support those heavily, just because I don't want any drooping.
Right.
And the triangles, to go back to that, I do lay it on edge. The only thing I support is the sensor details.
Okay.
Otherwise, I get droopage on the bottom edge of that because it's trying to print in midair.
That is true.
I'll just put 3 little supports on those, but otherwise the triangles get nothing.
So on these, you do fully support the bottom. That's another thing you can look at on how to set your support structure. There's a lot of settings on supports in there. To me, you need to test that out on your printer and find out what your separation layers need to be. Or you can now on S3D, now you can lay a top surface on there you can lay a full top surface on there. So that if you're printing something that needed a detail in the center, now you basically create a nice flat surface, just like your bed was, for the printer to now print on top of. So I guess that's a really another thing to talk about is software that we use. There's a lot to 3D printing. Is that what you gave up?
You like that?
Just open that box.
I get to sit back here and watch.
But again, on orientation, we do print these laying down flat with a lot of supports.
Got a side note.
Oh.
Erica Marys is asking, how are the 1-inch ball bearings? Erica Marys,
What about?
What are they asking?
how are? He said, ask Matt how my 1-inch ball bearings are holding up.
Oh, they're great. Thank you for letting me have them.
He says Silver City finally has them in
Yes.
stock.
Yes.
So you need a little more.
They're actually out because we bought all of
Your
them.
balls are okay.
Eric, this is Kerry. Want to let you know they're completely out of stock because I cleaned them out.
So in Carrie's drive, one of the parts that, and we thought we were going to have to redesign the whole support structure because we couldn't get the bearings anymore. So now Servo City has them. And back when I was, not anymore, we actually bought them. So the people that, well, there's a long story there. We'll explain that
Yes,
before we
it is.
get into that
Well,
one.
I cleaned them out today.
Yep.
So Eric, thanks for the ball bearings. And what that was is that I was back last year before Dragon Con. I had Dave's drive and we were getting ready to go, and all of a sudden we found out we weren't going to be able to get it ready. And I called Carrie and Stefan, I'm like, hey, can we get your drive ready within 2 to 3, it was 3 weeks. And Carrie and Stefan are like, yeah, we can do it. And we could not find the bearings. And then Eric says, hey, I've got 6 of them. I'm like, oh, you're great. So it was awesome. But that's part of the club. I mean, if anybody needs anything, always ask someone. Never be afraid to ask a question. If you're looking for something, you can't find it, post something on the club. Hey, somebody may have this bearing or somebody may have this servo that you need. So always just, be willing to use that. So what was the next question?
One of the things I would mention on there is the use of brims, because when you're putting like
But that was another
the edge
question.
of the triangle where it's literally one nozzle width, you may want to throw a brim on there to keep it from coming off the bed.
Have you guys used helper discs too? Just
Helper disc and brims are good things to use. So that's something you'll find if you print a part. So this is a good one. I mean, I don't use helper disc on these. I put a big brim on the outside, usually 10 layers or so. That puts a bigger surface on your bed. So now you've got a big flat surface there to stick down to.
Two things. So the number of brims you can run into, like Matt said, he does 10. I do 2. So like Matt was saying, every printer's different, every filament's different. One of the things that Stefan just brought up with the curving of the triangle that Bobby built the vertical support disc for, one of the things we found is we dropped the bed temp.
Yes.
I was originally using 55 to 60 for all my PLA prints, and I was getting that warp. We dropped it to the point where I think 45 finally cured it.
I think I dropped 230.
Yeah, realistically, what it came down to drop it to the point where you're no longer getting the warp, but it's still stuck to the bed.
It's finding that sweet spot.
It is, and a lot of this 3D printing, like you said, there is no out-of-the-box solution. You're not going to buy that roll of filament with that printer and put that file in it. It's going to be perfect.
you're in the wrong hobby if you expect it to be that
Yeah.
easy. It's going to take some play.
It's a huge learning curve. You can say they're pull out of the box. I mean, what is that, plug and play, basically? But it's not. It's something you're going to have to experiment with and learn what the process is.
It's the same thing I had with my Robo. You can get a Robo printer right now online that's pre-built for less than $400 through Amazon, and it's pretty close, but you're still going to have to mess with temperatures and stuff like that. And that's what my whole BB-8 is printed on, is just a half size of the newer printers now. So all my dome pieces are sectioned, all my panel pieces are sectioned. I'm not playing with the big boys like these guys that can do a full dome in one shot, because I just don't have the bed space for it. But if you can get, even like I said, even with some of the littler printers, you can still get them dialed in enough that you can print something just enough quality. It's just going to take a little bit more time.
And that goes just because you buy a $5,000 printer. We've got a guy in here that works on some $40,000 printers. They're not plug and play. You have to learn how to operate them. You're basically taking on another little job, learning how to run one of these. But once you figure it out, it's like working in the space industry. It's just, you change your parameters one at a time. That's the biggest thing, the biggest mistake in our field that's always made in R&D, is that you try to change 2 or 3 things, you don't know what fixed anything, or you don't know what caused the result that you got. And then you don't know which one to go back and adjust again. So always change one thing at a time. I didn't know there was another question. Software.
Yeah.
So let's talk about that. I've used a couple. The Raise comes with.
I don't know. I've never used it.
I have not used it.
Idea Maker.
Yeah.
Idea Maker.
Never tried.
I started and I did a lot of research on software. I think Cura is another one that's out there. Matter Control. I started out with S3D. I'm always one. I research everything before I make a decision. I ask questions. I want to see what people are doing. In the beginning, it does cost you $100, $150, I think, to get the software, but that's for life. And then they give you the updates and everything to go with it. It's well worth the money, especially with their new update that they've done. They gave you so much more control over, from like I was talking about, the support systems, all your temperature controls, the amount of profiles that you can store, and it's just a really easy program to use. And it allows you to make all kind of adjustments. You can see under your prints. So to me, that is one of the best ones to use. I think there's other people that are using other ones that can give you, and they may like those better, but that's my personal one. I think it's the same one Carrie's using, Stefan's using it, David's using it, Brad's using it. So it's almost everybody has went to that platform.
I want to say there's, at least there used to be
A year or two ago, there's a discount code for
There
the
is
BB-8
for the
builders
builders,
for S3D. And it's Simplified 3D, for those that don't
Simplified,
know.
yes.
Yeah.
I forget we use all the acronyms.
Yeah. Are there any more questions you guys have?
That we think of.
Okay. So the one thing I do want to plug is, I'm going to plug my dome.
I was just going to ask really quick. I stepped out for a minute. Did you talk about strength of shells compared to infill and how that affects things?
I did not. So that's 2 more variables. So again,
Go back.
Carrie's the one that has the most variables out of all of them. But it's really good. I like talking about it. So layers and infill, all of that. That's where you get your strength, your rigidity, but along with that comes weight. So there's a fine line on all of that. You need to know what you want to do with your part. A lot of the parts on Carrie's drive that I did, I wanted all results in those, so they're almost 100% infill on those. They're solid chunks of plastic. And it's what we have chosen to use, and it's what we'll provide to the club. This is the way we recommend to do something. And a lot of times when we put those recommendations out there, we put them out there for a reason. And that's because we have printed 50 of these things, and we found out what works, what cracks, what breaks. And again, you know, it may equal more time, equals a little bit more filament, but you end up with a part that's not going to fail. So in the end, you win. So it's learning about that. The dome that we've done, this one has 2 layers and then 5% infill. So basically all that infill is doing is tying those 2 layers on the outside to the 2 layers on the inside.
2 walls.
2 walls. That's correct. Layers is different. Layers you can go up. So you have 2 wall thickness, and then you also have your top and bottom layers. Your bottom layer can be thin sometimes. It depends on what you're doing again, where it's going to be at, if it's going to be attached to something else. Top layers depend on how you want that top layer to look or how strong you want it to be. I usually use 2 to 3 bottom layers and then 5 or 6 top layers. But again, it depends on what you're printing. This one uses 2 walls, 5 bottom, 5 top to get the structure on them. What happens on the top is that you need more layers to get the top surface to be smooth. Allows you to have a little bit more surface to sand on those. So again, I've got the dome. This is one of the domes that I'm going to offer to the club. It's not offered as a sale product. This is going to be offered as a printing service. So if you guys are interested in it, I think this is Paul's new dome, and it's coming in around 0.74 pounds. So we've gotten them about as light as we're going to get them. We actually talked to Matt today, Matt Denton, and we found out that we're spot on to where we need to be on the dome weights. We've got them down to 2 pounds, fully loaded, that are not spinning above the rim or the ring. So we've got them down to right around what the stage droids are running now, which was an awesome thing to find out today. So that was really cool. Thanks, Matt. Got any other questions? Good? Okay. Again, thanks to Kerry, thanks to his wife for inviting us out here. We've had a great time. Thanks to everyone for coming.
Thank you guys.